Right. Okay. So Fibonacci number, we want to talk about Fibonacci number today, and then we work on a logic for that. So Fibonacci. So the first element is said to be 1. Second element is said to be 1 as well. Third element onwards, basically we try to add the first two back. So it's basically previous plus the previous. So then we have the fourth element, which is, I guess in Excel this should be easy. We can just copy paste and we can create a series like that. Oops, sorry. Right, sixth element, who can tell me what is the sixth element going to be?
8.
Right. How about 10th element? Anybody?
13.
Not 7th, 10th, sorry. So 10th is going to be, looks like 55. Okay, cool. So, yeah, that's how the Fibonacci's work, numbers work. And the basic logic is simple, which is visible in this Excel sheet, equal to B. For example, third element, which is on line 5, looks back at fourth and the third element of this Excel sheet, fourth and third line of the Excel sheet. And similarly, the sixth line looks at the fifth and the fourth line of this Excel sheet. So that is what we need to do when we're going to calculate a Fibonacci number. Okay, any question or anything that surprises you in this so far? I hope not. Okay. Now the second thing we want to talk about is how do we do this in Java? Any suggestions from anyone on the call? Hi JP, we were just discussing Fibonacci numbers. Thanks for joining, JP. Right. So today I think we'll talk about few things. One of them is a function. So we will talk about a function and we'll call it, let's say, Fibo. And if I have to calculate the 10th number, what do I need to do? So I guess if I have to do Fibo of 10 with 10 being the argument, I need to calculate Fibo of 9 and Fibo of 8. So that's how roughly we're trying to break down the logic of the Fibonacci numbers. And we need to then remember the 8th and 9th number so that we can calculate the 10th number. So there are actually multiple ways to do it. One way is called recursion. Has anybody heard about it or used it before? And then we have the second option, which is for loop. And I'm sure for loop is quite well known. So today we will try to start solving the Fibonacci as a for loop. And so I'm going to write down the sequence. So let's use a variable called int num1, and then we will give it the value num1 equal to 1. This is our starting variable, this guy. So that's what we did this is in the Java style of declaring our variable and giving it away. Similarly, we will now need the second number, which is also started at the value of 2 as per this Excel sheet. So you have second element here, then we have the value 1. Okay, so uh, then we will introduce uh, num, and we will say num equal to num1 plus num2. So this way we should get the third element. Yeah, let's call it num this time instead of num1, num2, num3. We'll call it num. So this is our basic logic of calculating the third element. Are you guys with me so far? Like me more interactive will be good for me. Okay. So let's open our J shells and give it a go. JP, while I have you, I was thinking of because you already know Java very well. So I was hoping that you can actually work on efficient thread safe implementation of Fibonacci. Do you have something in your mind already?
Manu, today or
Um, no, whenever you have time, do you have any idea how will you implement it?
yeah, yeah, sure. Maybe I will work it out. I can send as a exercise.
Okay, sure. So
Yeah,
I
yeah.
guess the it should be efficient. It should support multi-threaded access. So
Okay,
assuming like an API which gives out keyboard number and multiple users calling that API.
okay,
So you need
sure.
to calculate with efficiency, speed, time, throughput, response, all the things.
Okay, sure. I'll work it out and send it as an exercise.
Okay. Okay, guys, I want everyone to open their JShell. Let me know if you are ready with JShell already. Does anybody want to share screen and show the working? Can I request one volunteer? So you're not able to get back from anybody. Okay, Jay is volunteering. So Jay, please share your shell or command prompt or terminal, and then let's try to work through this solution,
Yeah, sure.
this partial solution at least. I can't see though on your screen
Yeah, 1 minute actually. I'm
sharing. Okay.
I'm searching. So there is where
If you open command prompt or terminal, then we need to
no,
type in.
actually I'm trying to share my screen, so
Oh,
I'm not able to see any options to share or
okay. Is it so?
actually you need to, I think,
Maybe I'll stop presenting so you can share.
yes.
Okay. So that's a nice view. Let me stop. I think you need to increase the font a little bit more. It's still not that clear. Okay, you already implemented it, is it? Okay, good.
Yeah.
Super. Can you make it a little bit more bigger, the font? Yeah, and the screen itself, maybe we need a few more lines. Empty lines. Make it vertically, and it vertically. Anybody who has already done this part or facing any issue? Sorry, Jay, I tried to do multi-sharing. It seems like I can't see it anymore. I'll stop by and please share again. Okay, let's see. All right, so Jay, I want you to type a command which says num1 equal to num2. Single equal to. And num2 equal to num2 equal to num. Great. Now I want to repeat the command where num equal to num1 plus num2. Okay. So this should be our fourth element, and the value of the fourth element, as we saw in the Excel sheet, is supposed to be 3. So it's working fine. Okay. Anybody else who would like to share their J shell and show us the fifth element?
Yeah, let me stop screen.
Don't stop. I think
Okay.
let's see if there's any other volunteer. If not, then I'll ask you to repeat something. Okay.
Shall I, Manu?
Yeah. Okay. Go ahead, Mike. There you can stop. Thank you. All right. So
Sorry.
Mahalakshmi, I want you to repeat the last three commands one by one, which is num1 equal to num2,
Yeah,
then
sure.
num2 equal to num, and then yeah. Hi Abdul, we are just working on our Fibonacci, understanding of Fibonacci numbers and how do we do it in Java. So the fifth element should have been 5, and I can see the value here is also 5. So yeah, well done, Mahalakshmi. So I guess now we have a logic where we try to remember the two numbers, num1 and num2, calculate the next element, and then remember the latest one and the previous one for the next round. That's what we're basically doing here. Does everybody realize that?
Yes.
Cool. Anybody else who still not clear about the logic here? Thanks for sharing, Mahalakshmi. So I'll now share my screen.
Yeah.
I see a couple of thumbs up. Good. All right. So basically, what we did is we basically set this guy first element as num1, second element as num2, and then we said num equal to num1 plus num2. But we also did something else in the when we tried to work on the third element. What we did is we said num1 equals to num2 and num2 equal to num. So what we did is we calculated the new element, but we also made sure that we now remember the last two elements. And after that, just basically repeat this process for any number of elements. So that's the logic we're going to follow. All right. I hope it's clear to everybody. So now we will jump to Java to write a Java program. Give me a second. I'll save the shell script, shell prompt now, and we'll work on a Java program. I saw that Tapinder has joined, and Abdul has joined as well recently. Hi Tapinder, we were just working on Fibonacci. We were basically working out the logic that we're going to work on. So are you Abdul and Tapinder, because you guys joined late, can I quickly check if anybody of you does not understand Fibonacci numbers?
No, I know what is Fibonacci.
Okay. So what we're trying to do is we're trying to calculate, we're going to start with number equal to, the first number as 1, second number as 1, and the third number will be the addition. And then we'll basically remember the latest calculation and the previous number for the next round. That's the basic logic. Yeah. Okay. So I'm going to create a directory called session03 in my JavaBabies directory. Yeah. Everybody please follow. And then we will create a file called Fibonacci.java. Yeah. And as usual, we will start with public class, and the name of the file should be used as the Java class name. And then we will add our public static. Yeah, everybody please follow along. So we will try to code the Fibonacci number armed with the knowledge that we need to work on a look back kind of a logic. So let's start with let's say we want to use n as the element that you are interested in, like the third element or the fifth element or the 10th element. Yeah. So let's say that is n, and let's say you are interested in the 10th element, and which should be 55. So we'll double check that in the end. So now what we'll do is we'll calculate, we'll run a, we'll also need to declare the num1 and the num2. Similar to what we did in JSL, num1, num2. And where do we start? We start with num1 equal to 1, num2 equal to 1. And I'll save the file just so that I don't lose it, don't lose my work. Anybody who is not clear what I have done so far? Or is it obvious for everyone? I mean, in case you have any questions, just let me know. If there is no question, I will proceed with the next command, which is for loop. So today we are going to start a Fibonacci implementation using a for loop. How does the for loop work? You have the for keyword, then you open a parenthesis, and then you declare some sort of counter. So in this case, my counter will be, let's say, I, and where do I start? Because I already know the two numbers, first the number, so I will start. I'll start my counter from 2, which is basically in Java's world. Okay, let me start it from 3. So I'm going to start to work on the third element. That's why I'm writing int I equal to 3. So here what you're doing is you're declaring a local variable called I, and you're setting a value to 3. and how long I want to run my loop until I is less than or equal to 10 or n in fact, because we're talking about n being the number of elements and the nth element is what we're interested in. So we want the I to keep increasing until I is less than or equal to n, and then for every loop I want to increment the value of I by 1, and that's what I plus plus means. And this is how I declare my for loop. So once again, there is a for keyword, there is a parenthesis which has a closing counterpart to it. There is the block, so there's the opening block and the closing block, because I will write multiple statements. If there's a single statement, I did not need the block, but generally I prefer to write all the nested commands in a block. Then we declare a counter variable of type int. Start it from the third element because we want to, because the first two elements are already known. So that's why we start the loop at 3. And then how many times we loop? We loop for n times, starting from 3 until n, where n is the number of the element that we are interested in Fibonacci series. And then we have a I plus plus, which is a counter, incrementing the counter. Yeah. And then what we do, anybody want to suggest what should we do inside the for loop? We will just do what we did in shell, where num equal to num1 plus num2. Yeah. What else should we do in the loop? Anybody want to take a guess? Is this enough for our loop?
Num
to
is
work?
equal to num2, num2 is equal to num.
Yeah, that's great. That's great. All right. So, and what do we do in the end? We want to say, we'll basically do a printout. It will say system dot out dot. What command should we use? Any preference? My preference is println because it gives me some flexibility. So I will say the value of Fibonacci. Let's use capital F. Yeah. Fibonacci number is equal to, and then we pass the n as in the nth element and the value, which is num. So everybody with me so far?
We have to declare num as well. That is missing.
Yes, that's a good catch, Tapinder. I heard somebody else also. Somebody else? Okay. So yeah, I'll come back to that, Tapinder, in a minute. What do we do next? How do we compile the Java program? Using Java C command. Okay, and we find an error, compilation error, which says cannot find symbol num. Okay, and we find another error, cannot find symbol, and then we find another error, cannot find symbol, and all of them are pointing to num. So as Tapinder pointed out, we haven't declared num, so Java does not know what num means. Yeah, so we do int num. Now we know that we're declaring num as an integer, and let's see if the Java compiler is complaining again. Oh, it's still complaining. Okay, let's take a look. That's unexpected. Let's try one more time. Okay, something is not okay here. What's going on? Num might not have been initialized. Why is it complaining what num is? This is unexpected error. I haven't. Let's try another command. This, is anybody else facing this issue that I am facing? I think I've broken Java, looks like. Yeah, I guess I need somebody else to try this out. Any Jay, maybe you can try. Share your screen and try it.
Yeah, sure. I will.
I'm getting the same error.
Oh, that's, yeah, I guess I know why. So the issue happening here is that the for loop is not guaranteed to run. Which means if the for loop did not run, because let's say, in fact, we can give it a go shortly. If for loop did not run, then what will the value of num be? Anybody want to guess?
We need to give the value of num like 0.
Correct. So what happens if we don't do that?
It will assume like a null value.
Yeah, if it was a non-primitive type, you're right. It would have assumed a null value. But even then, if it's a local variable, it still expects it to be initialized. So maybe I can share my screen back. So the value of num is actually not guaranteed to be initialized, and Java does not let you do these kind of mistakes. It wants programmers to actually declare the value and definitely give them a starting value. That's why we need to declare some value. Otherwise, because the for loop is not guaranteed to run, means num may never get a value if you don't declare it here, as Mahalakshmi suggested. So now I have compiled the Java program after fixing that error, and when we run it, that does not look nice. We need to add some better printing. So we have a print app. So let me add a new line. Right. So now we come back to the 10th value, which is 55, as we calculated in our Excel sheet. Okay. Now this program, even though it's so simple, even then we managed to commit a mistake, which is considered a compilation issue. There are many other ways this program can go wrong. Let's do one thing. Instead of putting n equal to 10, I think this is not very helpful, not friendly. So what I want to do is I want to be able to say Java, give me the Java Fibonacci of 20. Yeah. Even when I want to run Java 20, it still gives me 1055. Let's say I wanted to run Java of 11, 12. Yeah. is still giving me 10 and 55. So not so friendly. So what we'll do is we'll convert n from a hard code value and we will read it from a arguments. Does everybody know how to do that? How do we read the arguments into an integer? We did it in the first session, so I think Tapender should be able to remember. Jay, do you remember this? How do we convert arguments? How do we take the command line argument? Okay, let me go to that one more time. So first of all, what does this mean is this basically carries the command line arguments for us. That's why we needed it here. So what we'll do is we will just pick it up. Yeah. So we will say this and try to make a print out of it. System.out.print f input values to my program. Right? %s, and maybe I'll put it in double quotes so that's visible to everyone. And then
arg0.
Yeah, we'll say arg0. So in fact, I should improve my statement here saying first input value to my program is, yeah. So we're not going to use it just now. I'm just going to demonstrate how does the parameter passing work, and it did not work. It again. Okay. So we missed a double quote here, and I guess we should have a new line while we are at it. So cannot find symbol ARGS. I think
In the first you have specify arg, not args.
okay, yeah. Usually I prefer args because it's plural for an array. So I change it to args. Thanks for pointing out. And then we run this again. And we're not expecting to calculate Fibonacci 12 yet, but we know that now our program recognizes our first argument. Yeah. And then the value of 10 is 55, which was asked for. So while we improve this, I want to do something else. I want to say that my program now basically expects a mandatory first argument. So what I'll say, if args is null or args dot, because it's an array, I can use args or length is less than 1. What should I do? I should throw a new illegal argument exception, and I can tell the user that expecting one command line argument. Okay, and this is my error message, and I'll close my if condition. Okay, so now I'll compile this guy and I will run it without any argument. And now I get an error that I'm expecting one command line argument. So that is the first thing I want to do to make my program fail fast. Yeah, that I tell everybody that I'm expecting one argument. In fact, I can do one more thing. I can say if the argument length is not equal to 1, yeah, then my program should throw an error at the start. So when there is no argument, it throws an error. If there are 2 arguments, oh, I think it did not pass it properly. Let me try something. Oh, sorry. L34. Then also it complains complains with the illegal argument, saying I'm expecting one command line. Yeah. So now we have made our program error. We're trying to improve the error proofness of the program. So this is the first step. Second step, is that now I know I'm always going to get at least one argument, and in this case, at most one argument. So I can safely refer to arg0 because I have already checked that arg should have length equal to 1, which because arrays are 0 index in Java, so arg0 should give me the first argument. Is it clear? Anybody has any question on this part?
Manu, actually, the throw now illegal argument exception, right? It
Yeah,
is our own exception or it's a built-in?
It's
Java
a built-in one. Built-in.
Oh, suppose if I don't know the exception, right, that other than illegal exception, so how do I know that I am passing the correct exception here?
Right. So in this case, so for example, I am talking about arguments, so I already know that it's an illegal argument kind of exception scenario. Correct?
Yep.
So at the start, if you're at the start of any function, if you're doing some checks about the input, then this is your favorite exception to go to. Then you have a runtime exception, which is basically when you don't know what to do, you throw a runtime exception. That's very common also. Which could happen somewhere here, where
Okay.
you end up in a logic where you don't know exactly what to do next. So then you throw runtime exception. Yeah. I guess we'll cover more details about exception at a later stage. So far, do you think this answer is enough for you?
Yeah. Thank you.
Okay, cool. Now that we have the argument, how do we make use of it? Tapendra, do you remember?
Yeah, assign it to as the argument.
How do I do that?
ARGS, then 0.
Correct, but we are interested in a number, in an integer, not a string. So by default, Java
Okay,
all the arguments are string. Yeah.
We can have int, then the number, specify the number.
So we have to do integer dot. So integer is a helper class in Java.
Yeah, parse.
It has a parseInt method
Yeah.
which can convert a string to an integer. So we will use this facility. Okay. So please take note. Maybe I'll add a comment here. Pass the first argument as an integer. Okay. That's the comment I'm adding. So here I will add a comment also. This is for my everybody's benefit. Expecting one and only one argument from command line. All right. So I think now what we have done is we have made our program more flexible, and it accepts a command line argument, which is the element which Fibonacci need to calculate. So let's try to run this guy. Okay, it compiles successfully. That's great. And if I run Java Fibonacci without any element, I'm still getting the illegal argument exception, which is also good because now we are in control. And if we pass a number 10, we should get an output of 55. Okay, it's working still, which means we did not cause any regression error, which is great. Now, if I want to calculate my 12th element, it's giving me a number 144. Anybody who thinks that value is correct or wrong? Okay, fine. So I just checked in my Excel sheet and I added the 11th and 12th element, and I am getting 144 also. So now the Java program is accurate. All right. Now I wanted to know if anybody here is able to reach this stage, or they want me to go through the program. I'll just open the Java file so everybody can compare and make sure that you all have the same output. Yeah. Okay, I'll hold here for a minute or two. And in case there's any question or anybody who's lagging behind, please catch up. And I feel that it's very important that we all do hands-on during the class, because we take enough time to pause and give everybody a chance to pause, so that you don't have to come back and spend more of your time trying to try out this program. So yeah, please do. Please try to implement this right away and let me know if there's any question.
Hey Manu, Vinith here. So I had one question. So I see in some cases you have started with caps like F capital, Fibonacci, and string is capital. So in static void and all, it's small. So when to use caps and small?
This one is definitely you cannot change this. I mean, you can, but the only thing you can change is this line is this guy. Yeah.
Okay.
Java will not care about the name of the variable that gets passed in with the command line values, but public static void main with the string array argument tells Java this is the program, this is the entry function that I need to call when I run this Fibonacci program. Now, this is the first part, most important. This part is a convention. So by default, usually people create a Java class with a capital name, camel case rather, I would say. The first alphabet capital, excuse me. So first alphabet capital, rest of the word in small case. And then if you have a second word, then you make the first alphabet of the second word capital and then rest of the small case as well. So this is called camel case. Yeah.
Okay, thank you.
Yeah. Thanks for the question. It was a good question. Cool. All right. Anybody wants to ask any other questions? All right. If not, then I would like to convert this into a smaller function. Yeah. So how do I add a function? I will just say, I'll add a new function called static int Fibo using for, and I'll pass it an argument n, and I'll just have to copy this logic here and return num. So what I've done just now is I've created a small function called Fibo using for, okay, and which also works on the n, which is whose job is to compute the nth element. And in this case, then I don't need all these lines. What I do need is to call this new function. So I will replace this logic to say to call the new function Fibo using for with the argument n, and then I'll print out as before. So let's see this dissection of the program, whether it works or not. It works. That's great. And whether it produces correct number, Java 10 is 155, 12 is 144. So we can see that we use a smaller function called Fibo using for and implemented the logic in a separate function, smaller function. So personally, I always favor small functions. They help the code become easier to read. They help become code easier to reason with. So, for example, if you trust this function, you've used it once or twice, and you trust it. And the next time when you come to this line, you know, oh, the number is going to be a Fibonacci number. Then you don't have to guess anymore. You don't have to review the for loop anymore. You know this guy works well. There are sufficient test cases for it. The regression passes all the regression tests and so on. So you trust this code, then you don't have to look at it again and again. You can park it in a different Java file also even. And this file becomes smaller, which is easier to understand and debug and talk about. Yeah, that's how programming, you improve your programming by having more meaningful code, which is easier, smaller, readable, maintainable, and so on. Okay. So we talked about one implementation of Fibonacci. I wanted to talk about a second implementation. which is using recursion. So has anybody worked on recursion before?
No.
Okay. Thanks for sharing. So here, this is our let's say arithmetic way, or let me call it for way, for loop way. Fibo using for loop. So we'll draw a parallel now, and we'll work on a recursion. So these two numbers are still known. So I'll just copy these two here, and I will say Fibo of 3 is equal to Fibo of 1 plus Fibo of 2. This is basically recursion, where you say my the value of my third element is equal to the value given by the same function with the argument 1 and plus the value of the same function argument 2. That's all that recursion is basically. So can you tell me how do I calculate the Fibonacci number, fourth element of Fibonacci? What should this look like? Yeah. Is any volunteer who wants to dictate what this statement would look like? So Fibo 4 equal to what? Equal to Fibo. What should I write here?
3 plus
3, correct. Plus Fibo
2.
2. Great. So we write, what happens when we write this line is that this part, let's color it differently. How do we do that? I'm not a good Google Sheet user while I try to find the highlighting option. Does it even have the coloring option? Let's call this way. So what happens when it does a Fibo of 3 is basically it goes back and calls this function. When it does a Fibo of 2, it goes back and uses this relationship. Okay. So basically there's a look back, but instead of remembering the look back via num1, num2, num, we actually look back using the function itself. Okay. And a function that calls itself is basically called recursion. Okay. So how will the code look like? I will say my static int Fibo int n will basically we'll put it very simply. In recursion there is one thing called terminal condition. Okay. So we need to tell the program that I want to terminate when should I terminate this program? When n is less than 3. If n is less than 3, my return value should be what? Will be either, okay, let me change this condition. If n is equal to 1, what should it do? Return 1. If n equal to 2, it should return 1. These are my two numbers at the start. Okay. First number, second number. And after that, I will say like int num equal to Fibo of n minus 1 plus Fibo n minus 2. And then I will say return my num. This is that's it. That's our recursion function. Okay. And later we'll try to break an exception and look at the factors as well. Yeah. Okay. All right. So this is what a recursion function would, how a recursive function can be used to implement Fibonacci. Okay. Is everybody okay that we try to implement it in our Java class now? All right. So let's go back here. So now, because we broke it into a new function, we can actually already start implementing a new function. Static in Fibo using, or let's say recursive. Yeah, let's call it recursive Fibo in n. I will say int if in this condition if now n is equal to 1. I will return 1.
The screen is not shared, I guess.
Sorry. So I'm sharing my screen now, and I'm going to add a new function called static int Fibo recursive, and we take the same argument and close this function off. And so we'll first write the terminal condition if n equal to 1. I will return 1 because Fibo of 1 is 1. Okay. Then we have another recursive condition which is n equal to 2. Sorry, we have another terminal condition n equal to 2 because Fibo of 2 is 1. Now, if it's not either of these base cases, we'll say int num equal to Fibo. Well, let's declare the num first, and then now we know there's an integer number, and then the number will be equal to Fibo recursive. So the function name should be as we declared above, n minus 1 plus Fibo recursive n minus 2. And lastly, return the num. That's it. Actually, you see, it's much smaller than the for loop. Yeah, interestingly. And we'll save it. We'll see there is no any compilation issue. Hopefully not. Yeah, great. So we just need to start using it. So we haven't used it so far. So this was our first implementation. So we will comment this line out, which says Fibo using for, and we'll replace it with Fibo recursive. And we'll save it, compile it once more time, and let's see if it still passes our previous test cases. Java of 10, Fibonacci of 10 should be 55. Great. Fibonacci of 12 will be 144. Cool. So we just now implemented Fibonacci using a recursive function. Although I know it's a bit confusing, this strategy, but it's a very important part of programming world. So I thought and Fibonacci is a very common use case for that. Does anybody have a question on the Fibonacci implementation using recursive?
Yes, I have a question. Like, if we are using a recursion, then won't we be using more function calls as
Yes, you're
compared
right.
to just a single one?
Correct, you're right. So let me do something about it. Let's say I'll add a dummy exception here to illustrate the point. Equal to, let's say, 4. Yeah. Row new runtime exception just to demonstrate stack calls. So what I'm saying is, if n is 4, then I want to abort this program and show you the stack trace. That's the reason I entered this particular condition. Okay. Did I do? Or the slash. Okay, so now if I run Java 12, what do we expect? We expect that there is exception hit when n is 4 and it shows me the stack trace. So you are right, Pankaj. You can see that it has been calling itself over and over again. So this probably being Fibonacci of 12, 11, 10, 9, 8, 7, 6, 5, 4. So that is as per our expectation. The stack calls look pretty ugly, you can say that. But that's one of the techniques. Some programs are actually this kind of, as long as the stack trace is not too high, like not like it's not going hundreds or thousands, then you will find this issue, not an issue. Yeah. For example, if we did let's say stack trace of 120, yeah, let's see what happens. Yeah, so we have so many calls. Let's say we have 1200. Wow, still supports. So apparently, even a 1200 stack trace did not cause this program to abort for other reasons except for our take condition. Yeah. So it depends on the memory that you're using. If your memory is not, you're not using too much memory, then a lot of stacks can be called. And in a commercial program, I see easily stacked calls of like 50 or so being very common. So I think, yeah, I think there's a too much advantage to be taken. The simplicity of the program basically deserves recursion in this case. Yeah, I can just say that. It's much more readable basically. Don't you think? So in fact, if I rename this function from Fibo recursive, just Fibo. So I just renamed the function from Fibo recursive to Fibo. So now, do you think this is very easy to read or no? It's very easy to understand also even, I would say. In fact, I can even simplify it further. I can just say return here itself. And I can remove these comments because they are obvious to me. So it still works correctly. Yeah. And it is much more readable. If you see what I mean. So that's why recursion is a very important part in the programming. It makes a lot of sense in some use cases. And it makes the program easy to read. Jay, do you have any questions?
No, Manu.
All right. So this is what I did for Fibonacci. Now I want to know. I wanted to know from you what happens when you do Fibo 5. Let's go on this guy. I think this is the last thing I want to cover today. What happens when I do Fibo of 5 and how we can do some improvement there basically. So Fibo 5 is going to call Fibo 4. Fibo 4 is so Fibo 5 will call Fibo 4, Fibo 4 will call Fibo 3, and Fibo 3 will be calculated. But Fibo 5 will also call Fibo 3, which will then call this again. So if you see, there is duplication happening because every time we call Fibo, it goes through the whole stack, as we just saw.
The
Yeah.
Excel file is not shared, Manu.
Yeah. Multiple. So thanks for that. And I have shared my Excel sheet now. So when we do Fibo 5, we have to call Fibo 4 and Fibo 3. Fibo3 calls this guy, which basically does the Fibo3 calculation. Fibo4 calls this guy, which calls Fibo3 again, which does this calculation and then adds Fibo2. So if you see Fibo5, we are calling this stack as well as this stack. It's a bit inefficient. Okay, so there's a technique called memoization. Memoization. So we talked about recursion. There's another technique called memoization. There's nothing fancy, just that we use a map to remember known results. That's it. Okay. So yeah, I'm going to go ahead and implement that. So let's leave this. I think it's very similar to recursion. I think we just need to add the 1 or 2 more lines. So let's call it static in Fibo memo. Let's call it Fibo memo in n. And I will still have the same terminal conditions.
Please share the terminal.
Yeah, I guess I'll try to implement it here first. So it's similar to this. It still is that. What I'll say is if my memory contains Fibo of n, then return that. Okay. And otherwise else calculate the new Fibo and remember the new Fibo. That's it basically. So we added one line here and we basically added some information in this part. That's the only change that we need to do. If my memory contains already the calculation, then we use that. If my memory does not remember the calculation, then get me that calculation and then remember it for the next term. Okay, that's all we need to do for adding memoization. So let me do it here. So I'm going to work on a new function called static in Fibo memo. I will have the same base condition. If n is 1 or 2, return 0. Otherwise, I will use a map variable. So map. So what I'll say, let's assume I have initialized a map variable, and then it says contains key n. Then what do we do? So then we'll say return map dot get the value. This is the Java way of using a map. Else. So I'm doing some assumption here that you guys are comfortable with the if else conditions. If not, I can just walk you through one more time here. Then I will just use the int num equal to Fibo memo n minus 1 plus Fibo memo n minus 2. Put inside my map. So map dot put n comma num and then return num. So what am I doing here? I am checking if my memory already has the solution. Then what I'm doing? We use the solution. Otherwise, calculate the solution using Fibo memo. Then what I'm doing? Remember new solution and then obviously return it. So this is the change. Now for this we need the map. So we'll have to declare the map. So I'm going to declare it as a static hash map of where the keys are of type integer and the values are of type integer as well. So what does this line do? We can go in detail after a few minutes. So what my Fibo memo does is it checks my memory. If it's there, we use the memory. Otherwise, calculate and put in the memory. Okay. Let's combine. Oh, I made the typo here, and I did. Okay, so there are, I guess, two errors. Hash map. It does not know what a hash map is, and Fibo Nino was misspelled as Pino memo. I'll fix those two. Pino. Fibo done. Now we're going to work on something called import statement. So when Java uses a class which is not available by default, we have to import it. So we will say import java.util.star. Yeah, let's see if that fixes the compilation. It does. So what we did is we imported utility classes from this package. So this represents a package name which we haven't come across yet, and we import all the classes from there. Yeah, this is a dependency injection kind of a stuff you can say from a code perspective, not from a runtime perspective. Okay, so we already have compiled, and let's run our Java. What I'm thinking is let's do some timing. Huh? So let's see if time Java 120. Sorry for that. We go for 20. Let's do it for 30. Or even 40. I'm just checking if the number is too large. Is 102 million. Still okay. So let's do Fibo 40. Yeah. One more time. Fibo 40. So let's remember this matrix. I'll post it on my Excel sheet. You guys also take a can take a try to remember that. So it looks like it took roughly 0. What happened? Okay, so it looks like it took around 273 milliseconds. Yeah, that's how we read it. Now we haven't still, although we have coded our memo program, we haven't really used it. So let's go back to the Java and start using the memorization example. So I will, which is here, let's say, so roughly line 21. So we'll comment out the initial usage of recursion and add memo to it so that the new program is now available. So we'll just compile and then we'll run this guy. All right, so let me run it one more time. There you go. So you see from 273 milliseconds, it came down to 72 milliseconds. User time from 249 milliseconds down to less than 60 milliseconds. So there's a factor of 10 So the program is sped up by 10 times, I would say. Okay. So these are a few techniques which we use to solve the same problem in different programming paradigms, you can say. For the sake of completeness, let's do timing of the for loop also, which I perceive should be the fastest. So now I'm going to use Fibo using for. Roughly in the line number 20, if you're following along. I commented out the Fibo and the Fibo memo using this guy, and we are going to compile it again and timing it. Right, this is actually similar to the time it took for the Fibo memo. All the same order, yeah? Maybe slightly faster, even by a millisecond. All right, so good results to store. Cool. So yeah, this is what I wanted to show you guys today. That we had 3 ways to implement one program using a for loop, using recursion with memorization or memoization. All right. So I'm going to switch back to the Excel sheet. Where I've noted down the results also for the for. And these two are for the recursion with and without memo. All right. I think that's all that I wanted to discuss today. Anybody got any questions? It'll be good if you have any questions, so that I guess it serves two purposes. One, it sort of validates your own thoughts, as well as it validates that whatever I've shared actually does go through the adds value to you. So yeah, I'll appreciate a couple of questions. And one point for JP. So we worked on 3 implementations. So right now, so the one that I asked you is basically next level, where the Fibo gets calculated in a multi-threaded way. Yeah. So I guess the calculation, the timing test would include sequential calculation of, let's say, 10 different numbers. Some of them are overlapping, versus timing of similar inputs, maybe 10 different numbers with some overlap, and in a multi-threaded way. Yeah. So please try to work it out, and hopefully the total time should be lesser than the time taken sequentially. Yeah.
Okay, man, sure.
Thank you. Yeah. So I think we don't want to do the multi-threaded version of Fibonacci here. It's going to be very advanced. So if there is no question, then we can call it a day. Yeah.
Sure.
Yeah.
Yeah, madam. Thank you.
Thanks, Mom.
Okay. Thank you, everyone, and have a nice weekend.
Yeah.
Thank you.
Bye-bye.
Thanks,
Thank you.
madam. Happy weekend. Bye.